Okay, this is just a video of our Camscope. This is a device that we use for production testing of camshafts and also checking and confirmation of measurements on any of the cams that we make at JWT. And what's of interest here is the in order to achieve the accuracy that we wanted, we had to do a few things differently than we did on our previous cam scopes. One of them is we had to move up to a pi turntable on this, which has very, very high resolution on it, pretty much down to about 1/1000th of a degree. The Heidenhain measuring device on this has the accuracy we want. We're looking at 5 millionths on accuracy, probably more realistically around 10 millionths. The Camscope software that we had to make in order to operate the unit will take measurements and stop for 20 milliseconds between measurements. That tends to settle the natural frequencies in the device itself, so the measurements are basically taken after all vibrations are settled out, and then moves on and continues. Typically we would do 1440 samples on a rotation of the cam lobe. We can move down the stick and do all of them, or what's kind of nice about this is a little more practical than fully automated, similar to an ADCO system, which is not as user-friendly for the type of information we're trying to derive. We can use a jog knob on this and move up to maybe the highest velocity points on the cam. Watching the Heidenhain display, we can move exactly 1 degree, 0 out, 1 degree, 0 out, and so forth, looking for increases in the height per degree until we find peak velocity without actually measuring the entire lobe and going back to that spot. Or we can be looking at if we have a spot that has heavy wear on a cam that's been previously run, we can go over to that spot and take a look at what the velocities were. If we broken through Hertzian contact stress there, it's usually going to be a high velocity point. Things like that. It's just very practical. The software that we built to operate it runs a stepper motor and interfaces with Excel to move the measurement over to Excel, where we can do pretty much what we want to on that end once we have the information. It's written in C#, fairly easy language to work with for this type of a thing. Had a lot of help from the people at US Digital putting the software together, as they make the little interface dongle that operates the jog knob, operates the stepper motor on the pi turntable, and also interfaces with the Heidenhain to move the measurements over to Excel. Unit is it's a QSB-M device that US Digital makes. They already have a complete library for C# and Visual Basic on it. Basically, if you just watch the video here, you see me go ahead and moving between the jog mode, which allows me to move to different places and take a look at measurements pretty quickly on the Heidenhain display, and then I can switch over to the measurement mode and then program in how many steps I want and what the increments of the steps would be. Hit enter, and basically it'll go ahead and move each measurement, stopping 20 milliseconds for settle time, take the picture, move to the next spot, and so on, recording all of that. When we're done, we have a complete data collection in Excel ready to do what we want with it. Pretty versatile. We built it based on what we actually use, in our testing and measurement. It turned out quite well. The measurements are extremely accurate. They're 6th place decimal measurements. They're very, very accurate and repeatable to within 10 millionths. As long as everything's set up and temperatures are normalized on the device, we can pretty much use that information to get an accurate jerk measurement of the production cam based on the engineering data, and compare that and see if we did a good job of manufacturing the lobe or not. It's also excellent to take a look at cams that may have been made in other places and evaluate whether harmonics are going to be satisfactory for a spring that we're building, or to compare to other cams that might be similar but have excessive jerk, which doesn't lend itself to using optimum spring pressures, and certainly not so good for high RPM. But as you take a look at what was going on with the system, you can see it's very accurate, but more importantly, hands-on inspection is quick, accurate, easy. Okay, right here is an example of getting ready to take a measurement mode data acquisition, and if you can see, Excel's open and you can see the measurements are going vertically down a column next to some previous data, and the unit will continue on until we're finished with what was commanded, and we'll have that record. Usually just put up a quick displacement map graphically, which you'll see. I'm gonna just cut this short here just so you can kind of see. Okay, and you can see an unfinished displacement graph there next to the graph for the existing data, and you can see we just did it over the nose of the cam right there, just so you can see how that comes out. Okay, and here I've switched over to jog mode. Clicked on the plus motion button, which has 180 degrees programmed in. It'll move exactly 180 degrees for me if I need to go over to that spot and take a look. Maybe I want to start a recording over there or whatever, but gives accurate, easy access to points that are not in absolute displacement to maybe a point that you've measured previously. Okay, and here's an example of using the jog knob. Jog knob is set to 1 degree increments. I'm just moving per click there. If you get 4 or 5 or 6 or whatever in there, it buffers that and will continue out until it's played out all of the clicks that you put in through the jog knob. The jog knob can be set to anywhere from full revolution of the cam per click down to 1.25 thousandths of a degree per click. And with the system set up the way that it is, the pretty much zero backlash. So when everything's set up properly, you can move forward and backwards and not see any resolution error from backlash. Occasionally down in the millionths, you're going to always be fighting stiction, so you want to be aware of any issues taking measurements going forward and then switching the measurements backwards. Not such a good idea. It's more appropriate that you make all your measurements in the same direction as a habit. We usually will go ahead and make one full revolution, which tends to load everything in the right direction, and when it stops via automation, then once it takes off again, all of that's resolved for, and get pretty good data from that. At first glance, it might seem like it takes an awful lot of time to record 1,440 points on a lobe, especially stopping 20 milliseconds between each data point on it. But we've tried a lot of different ways, and that comes out that it's the most accurate that we've found on this unit. However, there is a spot where you can eliminate the stops altogether, go ahead and take the measurements completely on the fly. You're going to also have vibration measured in with your data. It's not going to be adequate enough to actually get a relevant jerk measurement or third derivative measurement from your data on that. So with this unit, you can zero that out, or you can add 50 milliseconds or 100 milliseconds rest time in between. Doesn't really matter. You just have to pick what works good for the natural frequency of your device that you're using. In this case, we use two dead centers. On our previous Camscopes, we did have live centers, and we had the turntable rotating the one, but that entered an inaccuracy of the actual bearings in the turntable. That data was going to be added to any data from the lobe at that point. So in this design here, we have two dead centers, and the turntable itself only moves or contacts the dowel pin. So the contact at the dowel pin is the only rotating force on the cam, and the cam sits between two dead centers, which is probably the most accurate way to go ahead and pick up your measurements on that. Okay, here I'm programming in to make 10-degree moves and stop, and 10-degree move and stop, and so forth. If you look at the Heidenhain, you can see how stable the measurements are at the stop and the go on it. This is why the dead centers and all of the other little nuances of the machine that factor out vibration are worth it. Is that you can make these moves and get your numbers and be pretty assured that you've got a number representing what you're really measuring on it. That's kind of helpful if you have been frustrated by trying to do this with equipment that doesn't quite repeat itself. Okay, I'll try to pan in a little bit here so you can see the actual software, the Camscope software that interfaces all of this together. You can see on there we're in the jog mode right now, and basically got a scale that zeroes out when you need to locate where you are, and then move an incremental amount from that point. You can do that. Right now, just switch the toggle down that disarms the jog knob, and at that point, when you rotate the jog knob, nothing happens. And this is helpful when you want to zero out the numerators on the jog knob to 0 point after you've set the physical cam. And you can turn that back on and then start making your moves like we're doing right now. You can see on there we have a jog knob multiplier. It's important that's in the right position. When it's in 1:1, you're going to get 1.25 thousandths per movement of the knob. When it's in the multiplier, down at the lower left there is the number of pulses that you're going to get per click of the jog knob. To get around the cam a little bit faster, you can either pick to enter the number of steps or the number of degrees, which you can see right now we're moving by degrees. This is clicking the negative movement side, and go forward or back by number of degrees, or forward and back by number of steps. Now we've switched into the measurement mode. You can see the toggles have disappeared, and the number of steps that we want to move and number of measurements we want to take. You can enter that in there. You can get yourself over to Excel and go ahead and put your cursor where you'd like that information to start. Okay, so we'll click the top of the next column, and we'll hit the go button. Okay, and it'll go ahead and fill those in with the information that we want to get. And now, if you're still awake after watching this video, I want to apologize and also congratulate you that you share the same pursuit of excellence that we have always tried to achieve, and appreciate you watching our video.